Mathematics Level 4, Topic 3, Module 3. Topic 3, Space, Shape and Measurement. Module 3, Geometry, Part 2. Module 3, Session 1. Session 1 will cover Learning Outcome 3.2.2, Circle Theorems, Part 2. Learning Outcome 3.2.2, State and apply the theorems of circles. Welcome back. In the previous module, we covered the circle theorems. Our next group of theorems is related to cyclic quadrilaterals. Remember that a cyclic quad is a quadrilateral whose vertices all lie on the circumference of the same circle. Here we can see that vertices A, B, C, and D of this quadrilateral are concyclic. We are going to work through the theory and some examples of Theorem 5 and its converse, Theorem 6 and its converse. Theorem 5. The opposite angles of a cyclic quadrilateral are supplementary. In this diagram, we have a cyclic quadrilateral A, B, C, D. We can conclude that angle B plus angle D equals 180 degrees, and angle A plus angle C equals 180 degrees. When students use this theorem, they should use this abbreviation as a reason. Opposite angles, cyclic quad. The converse of Theorem 5 states that if the opposite angles of a quadrilateral are supplementary, the quadrilateral is a cyclic quadrilateral. In this diagram, if we know that angle B plus angle D equals 180 degrees and angle A plus angle C equals 180 degrees, then we can conclude that the points A, B, C, and D are concyclic, and A, B, C, D is a cyclic quadrilateral. When students use this theorem, they should use this abbreviation for a reason. Opposite angles supplementary. Let's watch a video of a lecturer applying this theorem.
In geometry, it is always important, once you view the diagram, to read the information that is linked to that diagram. This diagram means nothing without that information. Now, if you read the first sentence there, the vertices, what is vertices? That's angle A, angle B, angle C, angle D of the quad. Quad means we have 4 points here, lie on the circumference. You people can see this refers to the circumference of the circle. What does that mean? It means that point A, point B, point C, point D are all concyclic points. That means that statement there is telling us nothing other than A, B, C, D is a cyclic quad. Immediately, what does it mean further? Opposite angles, 3x and x, will add up to 180 degrees, and even the same with 2y, and y will also add up to 180 degrees. Now I look at my question. Determine the values of the unknown variables. Obviously, we have two variables here. We have x, which we can calculate, and we have y, which we can also calculate. Now let's solve this question. Let's first start with x. So we're going to say firstly 3x plus x is equal to 180 degrees. Why? They have tell me that ABCD is a cyclic quad. And because it's a cyclic quad, it implies that opposite angles, because those are the angles, opposite angles are supplementary. Supplementary, it means it adds up to 180. Obviously, this is a norm. Now it's an algebra problem. 3x plus 1x gives you 4x. And that is equal to 180 degrees. Therefore, x is equal to 180 degrees over 4. And that is equal to 45 degrees. Now we've solved the first variable. The second one, exactly the same. Y plus 2y is equal to 180 degrees. Exactly the same reason. 3y is equal to 180 degrees. Y therefore is equal to 180 degrees divided by 3, and it gives us a value for y of 60 degrees.
Theorem 6 states that an exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. In this diagram, we have cyclic quad A, B, C, D. Therefore, angle D1 equals angle B, and angle A1 equals angle C. To give this theorem as a reason, the abbreviation is exterior angle cyclic quad. The converse of this theorem is, if an exterior angle of a quadrilateral is equal to the interior opposite angle, the quadrilateral is a cyclic quadrilateral. If we are given that D1 equals B or that A1 equals C, we can conclude that ABCD is a cyclic quadrilateral. The reason is abbreviated as exterior angle equals interior opposite angle. Let's see how this theorem can be applied in an example.
If we look at the following example, they want the values of the unknown variables. Let's stop there. What are the unknown variables? The value of x, the value of y, the value of z. Please take note, people. It shouldn't be answered in the sequence of the alphabet. Finally, if we can just state the value of x, y, and z, then we've answered this question. And then let's look at what do they give me in order to answer this question. The first thing they said, BD is the diameter. Immediately I stop there. When I look at the diameter divides this circle into two halves. Z, we all can see there is subtended by the diameter. And the angle that's subtended by the diameter is 90 degrees. So in other words, Z will be equal to 90 degrees. The next thing they've given me the angle of 110 degrees. D1 is the supplementary adjacent angle to that one, which means D1 will be equal to 70 degrees, because those two must add up to 180 degrees. Then I see I got a triangle BCD. Y is the third angle of this triangle. I already have the other two. 90 plus 70 plus y should give me 180 degrees, because these are the interior angles of triangle BCD. In other words, 180 minus 90 gives me 90, minus 70 gives me 20. Obviously, y should be equal to 20 degrees. I'm just doing an analysis of what that information means. Then, when I look here, I see B, circumference, concyclic point, A, circumference, concyclic point, C, circumference, D, circumference, and B. You will agree with me, based on that, BACD is a cyclic quad. And this 110 degrees is the exterior angle of that cyclic quad. In other words, what do we know about cyclic quads? Exterior angle is equal to the opposite interior angle. That means x should be equal to 110 degrees. Now we have answered the question, and now we're just going to write it in a proper format. The first thing that we've solved was z, so we can straight away say z is equal to 90 degrees. Remember, I like the saying, angle in semicircle. Right. After z, we have found y. Is that correct? But how did we find y? We have first calculated d1. So d1 is equal to 180 degrees minus 110 degrees, and d1 was equal to 70 degrees. Why? Because this is adjacent, supplementary. Angles. Then the next one we've solved was y. Obviously, y will be equal to 180 degrees minus d1 plus z. Y, interior angles of triangle. And it's very important to be specific. We're referring to triangle BCD. And that gives me 180 minus, what was D1? D1 was 70. What was Z? Z was 90. And Y is equal to 20 degrees. And then obviously x is equal to 110 degrees. Y, exterior angle of cyclic what? Cyclic quad equals interior opposite angle.
Now try this activity on your own or in pairs. A, B, C, E is a cyclic quadrilateral. Determine the magnitude of A, angle BAC, and B, angle ACE. Here is a video of a lecturer taking us through the solution.
ABCE is a cyclic quadrilateral. Determine the magnitude of angle A formed by BAC. So you're looking at, we want the magnitude of A formed by BAC. We are interested in angle A. We have to understand that we'll be looking at a triangle of this nature. Let me just demonstrate that here. So you're looking at a triangle of this nature. Something more or less like this. So you're looking at A here, B, C. What we're interested in angle A from this demonstration. It comes with some understanding or necessary understanding. For instance, if you're looking at B, C, E, so you're looking at angle C formed by B, C, E, looking at this part. If you're looking at there, D, E, actually DC DCB, you can include F if you want, is equal to 180 degrees. It is a straight line. And on that straight line, we know that this angle here, this outside angle of DCE, is equal to 80. Therefore, to find angle C formed by BCE, we would say should be equal to 180 degrees, which is a straight line, subtracting 80, which then gives us 100 degrees. So we know that this, if you're looking at BCE, if you're looking at this big portion here, looking at that green region there, that angle is 100 degrees. We got that. Now, we also have to understand that angle C plus angle A plus angle A of a different triangle, they should be equal to 180 degrees. Let's look at these angles quickly. So you're looking at angle C of BCE. So we're looking at this angle plus BAC. So you're looking at BAC, which is this angle here. So this angle plus that angle plus CAE, looking at CAE, so that outside triangle there, they should be equal to 180 degrees. So the reason for this, it's opposite angles of a cyclic quad. So it's opposite angles of a cyclic quadrilateral. That's the reason for this notation. With that being said, we have calculated this part. Here is it. So this becomes 100 plus BAC, that's what we want, plus CAE, which is equal to 40 degrees. All of that should be equal to 180 degrees. Collect like terms. Your unknown kept on the left equals to what was on the right hand side, minus 100 minus 40. So this is 140. So 180 minus 140 is equal to 40 degrees. So angle A formed by BAC is equal to 40 degrees. So this angle is equal to 40 degrees. That's what we wanted to find out. Now let's look at number B. Number B says that you must determine angle C formed by ACE. Now let's come back to our demonstration. You're looking at ACE. We are looking at just this portion here. So let us again draw that triangle. So we're looking at a triangle which looks more like this. And what are we interested in? We're interested in angle C. It's always important to extract a triangle from that demonstration or from that diagram so that it will be easy for you to understand. So when you have done that, after your final answer, like here, if our answer here was 95 degrees and you look at the gap of this, it would have been clear to us that something was terribly wrong. We might have done a mistake here. So it's good to know that also for our final answer here, we are looking at something around This is not drawn to scale, but you're looking at something less than 90, but above 45. So you're looking at an angle of that magnitude. Now let's use our calculations. So we know that angle ABC, which is this angle here, should be equal to 180 degrees minus 70 degrees. So you take this out. So angle B, if you want to form angle B here, you will just take away 70, then the remainder would be that. So which then gives you 110 degrees. So we know that angle B is equal to 110 degrees. So because why? BC is a straight line in line with F. So this is 180 minus that gives you the inside, which I can extrapolate in green. So it wants the inside here. So you can see the stretching of that angle. That angle looks something like this. So the magnitude of it, you can see that it's more than 90. Hence we got 110 here. How does that help us? It helps us to understand this. Why is this so? So we're looking at angle AEC. AEC, which is what we want. AEC plus ABC. ABC should be equal to 180 degrees. What's the reason for that? Opposite angles of a cyclic quadrilateral. That's the reason for that. Therefore, once we know that we have found ABC, it's easy to substitute. Plus ABC, which was previously calculated as 110 degrees, should be equal to 180 degrees. Therefore, angle E of triangle AEC should be equal to 180 degrees subtract 110 degrees, which should give us 70 degrees.
Please work in groups to do this activity, which combines different theorems. Given this diagram where BOD equals 100 degrees and ABD equals 70 degrees, find the angles listed and give the reason for each answer. Let's watch a lecturer working through the solution.
Let's consider the following given diagram that we have in front of us, and let's look at the information that they provide. Let's ignore for a moment all the questions and then first find out what we can calculate from the given information. And thereafter, it's nice to play around. Let's look at the different type of questions. So I'm not going to look at any of the questions. I'm just going to look at what is given, and then immediately based on what is given, what can be calculated from the given information. If we look, they said BOD is equal to 100. That is a center angle. And if BOD is equal to 100, it means that this angle here will be equal to half of 100, which will be equal to 50 degrees. If BOD is equal to 100, it means that this reflex angle here will be equal to 260 degrees. Because of the fact that angles around the point must add up to 360 degrees. So this is 100 plus 260 gives you 360 degrees. And if that, as the center angle is 260 degrees, then obviously this angle here, but I will put it there, will be equal to 1 130 degrees. Right. And that's the angles that I can calculate from that given 100. I can first calculate the reflex angles around a point. I can calculate the angle at the circumference, which will be half of that. I can also calculate angle at that circumference, which will be half of that. Now I look at that 70-degree angle. I look at that 70-degree angle. If you look at that 70-degree angle, you can see DA subtends that 70-degree angle. But you can also see that, now we need to be very careful, this portion here, DA also subtends this small angle here. So in other words, I'm going to use this angle also as 70 degrees. And it's referring to this one. The bigger one is 130. That means that's 70. Obviously, this part here will then be equal to 60 degrees. Because 60 plus 70 should give me 130 degrees. Now, if I look further here in this diagram, then I can also see that AC, seeing that it goes through my center point, that is my diameter. And now, when it comes to diameter, can you see this diameter subtends that angle there, ABC? This whole one here should be 90 degrees because diameter subtended ABC, they have 70, which means this one here will be equal to 20 degrees because the whole angle here, this one, diameter subtends, the whole angle here should be equal to 90 degrees. And now, obviously, let's look at what do they want me to calculate. The first question here is, they want me to calculate BAD. If you look at BAD, we have already calculated BAD. BAD is equal to 50 degrees. There's nothing that I had to calculate before that because it is linked from the center to the circumference. So I can write down the statement straight away. BAD is equal to, obviously, 100 divided by 2, and that is equal to 50 degrees. What is my reasoning? My reasoning is angle at center is equal to 2 times angle at circumference. Right. Number 2. They want BCD. BCD, we've calculated BCD as equal to 130 degrees. But before that, we first had to calculate the reflex angle of BOD. So in other words, we're going to start off by writing reflex. BOD is equal to 360 minus 100. And that is equal to 260. What's the reason there? Angles around point O. And then, once I go that, now I can calculate BCD. BCD will be equal to that 260 divided by 2, and that is equal to 130 degrees. Same reason, angle at center is equal to 2 times angle at circum. circumference. Right. Then now we go to number 3. Angle ABC. You can see the angle ABC, straightforward. Angle ABC. That's the angle that are subtended by our diameter, and that is equal to 90 degrees. Why? We can say angle in semicircle or angle subtended by diameter. Angle in semicircle. Then number 4, BAE. BAE plus angle BAD will give you obviously you don't need to look further here because you've already got this angle here. So that one will obviously be 130 degrees because these two are adjacent supplementary angles. So you can say number 4, BAE is equal to 180 based on the diagram minus 50, and that is equal to 130 degrees. What's the reason? Adjacent, supplementary. Angles. If you look at number 5, they want ACD. ACD, we've already calculated as 70. So we're going to say ACD is equal to 70 degrees. And the reason is it is subtended by the same chord AD. So in other words, angles subtended by chord AD. Now, what we can derive here is that if you look at BAE, that's 130, and if you look at BCD, that's also 130. From that, we can deduce that this is the external angle of cyclic quad ABCD, which means you could have also gone that route in order to find the value of BAE. And that is what makes geometry very, very interesting, because there's no fixed method in order to apply to find certain values. Depending on the information at hand, you can go any route, but always try and use the easiest route as possible.
Before moving on to our last group of circle theorems, we'll summarize our cyclic quad theorems. Theorem 5. The opposite angles of a cyclic quad are supplementary to each other, and its converse, if opposite angles of a quadrilateral are supplementary, then it is a cyclic quadrilateral. Theorem 6 states that the external angle of a cyclic quad is equal to its opposite internal angle. Its converse states that if the external angle of a quadrilateral is equal to the opposite internal angle, then it is a cyclic quadrilateral.